Okay, so let's go ahead and continue with the review packet on number 5. It says evaluate the following expressions, give exact answers. Now I'll give you a little hint here that drawing a triangle in the correct quadrant may help. Every single one of these problems produces some type of angle, and then we're taking whatever function is on the outside of that. So for instance, we're going to take the cosine of whatever angle this produces. Okay? So what I want you guys to understand is that anytime you have this inverse here, that means we're going to get some type of angle. I'm going to call that theta. So I'm going to draw an angle for each one of these that represents theta in the appropriate quadrant. But before I draw any type of triangles, let me go ahead and remind everybody of where these functions exist. So for instance, the inverse cosine only exists in the first two quadrants. Inverse sine and tangent only exists in the first and fourth quadrant. So that kind of tells us where we're allowed to draw these triangles at. If we didn't restrict these domains, then we would have multiple triangles, we'd have multiple answers. We don't want that. So what I'm going to do is use the 5/12 to draw my triangle, and it's positive. So tangent is positive in the first quadrant. So I'm going to draw my right triangle. Remember, we always start at the origin. We come out into the space, and then we drop a perpendicular line to the x-axis. Now it says tangent, so that means opposite over adjacent. So that's 5/12. Here's my angle that I'm talking about. Before I go any further, maybe I should remind everybody of SOHCAHTOA. Probably by far the easiest way to remember these functions. So remember that the sine is equal to O over H, cosine is equal to adjacent over hypotenuse, and the tangent is equal to opposite over adjacent. So there's just a quick reminder of that, so let's keep going. Now it's telling us to find the cosine of that angle, so I'm going to write cosine of theta is equal to 12 over the hypotenuse. Well, I don't have the hypotenuse yet, do I? We can easily find that using the Pythagorean theorem, and when we do that, the hypotenuse comes out to be 13. Okay, so I put 13 on the bottom here, and I'm all done. My final answer of 12 over 13. So I'll try to go a little bit quicker with these other ones. So again, this is going to give us an angle. It's a negative, so sine is negative in the fourth quadrant. So I'm going to draw my fourth quadrant triangle. Not really worried about drawing it to scale. This diagram is just to help us organize the information. Sine is opposite over adjacent, so I'm going to put my 3 and my square root of 13. Oh, I'm sorry, I said opposite over adjacent. Opposite over hypotenuse. Okay, sorry about that. Now we do have that negative symbol in here, so we can't forget about that. So we don't put the negative on the hypotenuse, that doesn't really make sense. We put it on the x or y, so in this case we have a negative 3 here. Okay, we use Pythagorean theorem again. We're going to get the value for the x direction is 2. So what do I have here? I have the tangent of theta equals opposite over adjacent. So I have negative 3 over 2. And that's my final answer. It's nice here in part C and D, if you notice, we have the same exact angle that's going to be formed. So I can just draw one triangle and use that for both these problems. So again, cosine is positive, so I'm going to draw that in the first quadrant. Cosine is adjacent over hypotenuse, so I put the 9 on the x-axis, the 15 on the radius or the hypotenuse of the triangle. Use the Pythagorean theorem, you'll get that the opposite side is 12. So what do we want? We want the secant of theta, which is the reciprocal of cosine. So really that just means we're flipping the cosine value upside down. So this is the more formal way of writing it. We already know the cosine value, that's adjacent over the hypotenuse. Or if we simplify this fraction, we get 15 over 9. Okay, so again, the secant, that means hypotenuse over adjacent side. Okay, great. So let's use that to complete part D, that triangle that is. So now it's asking for the cosecant of theta. Well, the cosecant of theta, a little note here, is the reciprocal of sine. So sine is opposite over hypotenuse. So the reciprocal of that is hypotenuse over opposite. All I have to do is plug in my values, which I already had. And I get a value, and I get a reduced fraction. I'm going to go back and reduce the other fraction too. Should have done that already. Of 5/4. So let me go back real quick and reduce this fraction here. It's the right answer, but just not reduced. 15 over 9 reduces to 5/3 or 5 over 3. Okay, alright, let's move on to the last problem of this packet. Following chart gives the estimated temperatures in North Carolina for the year 2001. So we have the X and the Y, typically how they organize this information, and we see that we have pretty much almost an entire year. We have up to 355 days. We know there's 365 days in a year, so this is almost the entire year. It tells us to determine the equation of the curve of best fit for the data by using a sinusoidal regression. So sinusoidal regression means, or should send a red flag off, tells you that, okay, we're going to be using our calculator for this problem. There is a way to do it by hand, but that's a little bit messier, so we're going to let technology do the work for us. So what I'm going to do is I'm going to go into my calculator, and I'm going to make sure it's on, of course. Whoops, let me get out of there. I'm already showing you what it's looking like. Okay, first thing you want to do is hit Stat. Then you're going to hit Enter. You're going to put your values in L1 and L2. Make sure that they're going into L1 and L2. If you don't see L1 and L2 there, let me know and I will help you get that back on your calculator. You have to do a little bit of resetting, maybe look in the catalog to get those back. Sometimes they get deleted on accident. So anyways, once you have all your values in, I strongly suggest that you go through and check and make sure everything's correct before you go any further. You don't want to go through and answer parts B, C, and D if your equation's wrong. Then you're going to have to redo everything. So anyways, make sure your answers or numbers are correct. Now we're going to hit Stat. We're going to hit Calc. We're trying to calculate the line of best fit or the sinusoidal regression. I'm going to scroll down to, I believe it's option C on my calculator. Might be something different on yours, but it should say SynReg. I'm going to hit Enter, and then I'm going to hit Enter, and our equation should come up. Okay, great. So we have an equation of y equals 23.38 if we round, times the sine of 0.02x minus 1.35 plus 61.25. So let me go ahead and write that equation down. Again, we have y equals 23.38 sine of 0.02x minus the 1.35 plus the 61.25. Alright, great. So we've answered the first part, we can check that off. Now it says record the regression, we did that, and sketch the points. Okay, that I trust that you can go ahead and sketch the points on the graph. One thing I want to note though is that when you go ahead and sketch the points on a test or quiz or something that's being graded, you want to make sure that you're very accurate with everything. You want to make sure that you label your x and y axis. So our x was time, and the units for that they were using were days. Our y-axis is the temperature, and I forgot to include in this problem that it should be Fahrenheit, so sorry about that. And if you look at our table of values, our largest x value is 355, our largest y value is 84. So it might make sense to make your table go up to about 100. I'm sorry, not your table, your axis, go up to about 100 for the y-axis, and I don't know, about 400 for your days. But you can make that however you like. Just make sure you do label it. 400 is easy to break up. So is 100, right? We can break that into 4 quarters. So we have 25, 50, and then 75. And then I know that you guys are all capable of going ahead and plotting the points. Just make sure, again, if it's a test or quiz, make sure it's accurate. You will get points deducted if it is inaccurate, so be careful. So moving on to the other questions that we have here. Part B says, what is the vertical shift of your regression equation? Well, the vertical shift is that last value, that D value. Okay, so the last value of our equation is 61.25. And then they say, what is the significance of that? Well, the significance of that number is that that's just the average temp. Okay, so let's take a look at that on our calculator and see what that really looks like when I say average temp, what I'm talking about. So if I go to my window, I've already have mine set up, but I set it up just like our graph here is. I don't really worry about the x scale and the y scale, but I did put on x min of 0, because that's where our x values start, all the way up to 400. Then my y min is 0, all the way up to 100. And if you want to see some points on your calculator, we want to hit second, stat plot, and make sure the stat plot's on. Also, make sure that it says L1 and L2. This is telling the calculator where to grab the data from. Okay, so it's set up correctly. So what I'm going to do is I'm going to hit graph, and I should see the points. Okay, great, there we go. So if I go to y equals and I just graph that 61.25 number, or 61.25, what's going to happen is it's going to cut the graph in half. So let's take a look. Okay, there we go. So that's like our center line. So that's basically telling us like that's okay. That's like the average temperature. And that kind of makes sense visually because the average we typically tend to think is like the middle number, or you know, what best represents all the data. And I kind of misspoke there. I didn't mean to say the middle number, but usually it's the number that summarizes the data. So this is right in the center of all these data points, and that's our average temperature. Okay. If I was saying middle number, I would be talking about the median, but we're not talking about that here. We're talking about the average temperature. Okay, great. So let's go ahead and answer some of the other questions. Finish this up. What is the amplitude of your regression equation? Well, the amplitude is just the number that's in front of the sign. So what's being multiplied by the sign basically tells us how tall the graph is from the center line. So anyways, our answer is 23.38. And what does this represent, or what's the significance of it? Well, the range of temperatures when multiplied by 2. So let's take a look at that. What that means, the range of the temperatures when multiplied by 2. Well, if we multiply this number by 2, well, what do we get? Let's go back to our calculator. Let's use that. $23.28. Oops, 38. Times 2 equals 46.76. So our range, let's go back to our problem here, the range, if they asked us for that, equals 46.76. Okay. And if we take the highest and lowest number, that's typically how we find the range. But this is an approximation. But if we go back up here, the highest number for the temperatures was 84. We subtract the lowest number, which was looks like 40. We get a range value of 44, which is pretty close to what our approximation told us when looking at the numbers from the equation. Range is 46.76. According to the actual points, it's 44. Pretty close. And the very last part of this, it asks us, use your regression equation from part A to predict the temperature in North Carolina on the 157th day of the year. You have to do something with this 157. You think to yourself, okay, well, what does 157th day mean? Is that the X or the Y values? Well, what do we put on our, where do we put our days? Do we put that on the X or Y? Put that on the X. So we're going to substitute the 157 in where we see X in our equation. So I'm going to write Y equals 23.38 sine 0.02 157 minus the 1.35 plus 61.25. Well, what do we get? We get 80.9 degrees. So approximately 80.9 degrees is our final answer.